I am going to present the final project, which is predicting temperature. And here is all of the package that I am going to use for this assignment. And just mentioned right here is the early stepping that I'm going to use in building the model. Um, all right. So for the dataset, for the training dataset, I set up the date into the index for the training purpose. I also having the data train information right here, then input the data test, and then the data test output I also included. So before the data preprocessing, I looking a little bit into the data exploration, since I want to see how the each variable distributed. We can see that the each there is a big gap between different variable. It's very hard to see, so I create another plot to see each individual variable how they are distributed and what's the graph look like. And sure, for sure, they really need the normalization uh, in this training data set. I also create the heat map correlation between variables, and a couple of them are very highly correlated. For example, RHO. However, we're not gonna doing anything with the variable here because we want to keep them all for the assignment purpose. Data preprocessing, I using the z-score normalization. After that, I also having a function for reverse normalization, which is used for later purpose after the modeling. I I have a normalization for the training test and testing set. I also have to reshape since the requirement is 24 hours. We're gonna predicting the next 25th hours based on the 24th hours. So we need to reshape the training set into a different shape. So here is the shape that we had after the reshape. So all right. So after the pre-processing, here is come to the modeling. So I did a little bit in the training, and so we had the training and X train. I split the data into the training set into X train and Y train, and also reshape the X train that's gonna be fit used for the LSTM baseline. Uh, so here is just the symbol basic LSTM baseline. Alright, so we get the score for it is 0.05. Here's the plot. And then as for the prediction, I want to make prediction on the test data. And here is the y hat, which is what I use to see how close the values compare with the sample. Here's the IMSE score, which is 0.476, which is very high, pretty high, pretty high uh, project baseline. Then from here, stacking one more layer of LSTM with activation is linear. So we get the score of it is 0.06, which is higher than the baseline, and the plot is actually a little bit different. And here we get the RMSE is 7.6. It is extremely high. RMSE, which is not good. So I try a different approach by splitting the data into trend and valid with the test size 0.2. uh, and then I add one more LSTM layer, and also they increase the epoch to 50, batch size 56, and with implementation of this early stopping. So from here I got the score is 0.06, with IMSE 66, which is not a good score. So I moved to different direction by applying times distribute. So from the base LSTM, I adding time distribute. Still implementing the early stopping. So I got the score is 0.053, and the RMS is 1.63 so it's actually a good score, an okay score. However, as you can see that the plot right here, it seems to be overfit. That's why I adding the recurrent dropout. So everything gonna be the same with the last model, but the only difference is adding the recurrent dropout is 0.4. So from here I got the score is 0.06. Uh, and the RMSE is 0.58, which is improving. However, compared to the baseline, it's still not as good as the baseline. From that, from here, I actually try out the convolutional 1D with the LSTM, and then I add the dropout, also the recurrent dropout, because because it could be overfit. So that's why dropout is necessary. I also reduce the unit is 220. The filter is 32 kernel size 3 for the convolutional. Also applying the epoch is 50 and adding the early stopping right here. So the model running to 33 epoch instead of 50, and it stop. So the score we got is 0.056. Here's the model, and the IMS is actually very good. Uh, is smaller than the baseline. So the IMS in here is 0.34, which is so which is the best score for this assignment that I had. And when I apply into the Kaggle, it's actually higher than the submission from professor for the MAE score. So that's what that's all I do for this assignment. Thank you.